Welcome to Unconventionally Python. This presentation is about iterations, also known as loops. In this segment, we will examine repetitions by using the for structure in creating a finite number of iterations. We have used repetition when we studied the move method, but now we will take a closer look of repetition structures, mechanisms by which a line or many lines of code execute time and again. Just to refresh your memory, what you see here is the initial Python code related to the circle queue objects that we were moving from one location to another. And looking at the code, we observe that lines 17 and 18 are the same as lines 20 and 21, 23 and 24, etc., etc., etc. There is a programming structure intended to perform repetition. The Python repetition command starts with the reserved word for, followed by a variable, in this example I, followed by the reserved words in range, and within the parentheses we set a value, a constant or a variable that indicates the number of desired iterations, also known as loops. In our example, we have entered 15. In other words, we tell the system that we would like the followed indented code to execute 15 times. I assume that it is obvious that the code to the right is much more efficient than the code to the left, and in the code to the right, we may change in the range the number 15 to any number, and the indented code, in this example the line 17 and 18, will be executed many times, or as many times as we want. Let's examine line 14, the for statement, a little bit closer. In order to achieve repetition, we start with the word for, which is a key word, it's a reserved word, and the for indicates the beginning of the repetition structure. The I is a plain variable. You can use any name you want. I just decided to use the name I. Follow the variable I, we have in range parenthesis colon, and that is a set of keywords that tell the computer that the variable, in our example, the variable I, will be assigned some values. The first value that will be assigned to I is 0. That is by design. And after each repetition, the I value will increase by 1. The last value to be assigned to I would be, in this example, the value 14. Thus, the statement range parenthesis 15 indicates a set of numbers from 0 to 1 less than the number in the range parenthesis, which is in our example will be 14. We will examine the concept of range and its complexities at a later time. Also remember at this point that the colon at the end of the for statement is required. Again, in our example, the loop, the repetition structure, it will repeat, will execute lines 17 and 18 15 times. Let's see another example of repetition with the for structure. To the left, you see the code. To the right, you see the output. That's the meaning of print. We'll discuss this another time. We see to the right the output of the code. The variable num in the range assumes some value, and its value, it will be the result of line 2. So in line 3, the variable num will be the result of line 2, which is an assignment and says the value of num is 6. So if we can see inside the computer on line 3, the for statement, it says that the variable x will be a number in the range from 0 to 6. So we're going to repeat the indented code below the for as many times as the variable num. In our example, it will repeat that 6 times. Furthermore, on line 4 at the end, we display the value of the variable x. So every time we go around, we'll display the var x value. So we see from the output that initially the var x value is 0. We print it out. We go back to the for statement. The var x becomes 1. We print back. The var x will become 2. Print, etc., etc., etc. Hopefully, this small example and its output will clarify a few things in relation to the variable we're using after the for statement, the notion of the range, and the concept that the variable after the for, in our example, the var x, will take values from 0, and then 1, and then 2, and then 3, and then 4, etc., etc., etc. I would like to conclude this presentation by pointing out that we use loops, iterations, to improve the efficiency of a program. To the left, you see the inefficient way. To the right, lines 14 through 18, they represent a much more efficient development of a concept, and always we strive for efficiency. That's it for the moment. Thank you for attending this unconventionally Python presentation about iterations, the for structure. Thank you.